Please.
Oh, why are graph is saying that the red buggy is actually faster than the blue buggy? Because the red on the graph, the red buggy actually has covered more distance for a fair amount of time, while the blue buggy covered less distance for a fair amount of time. Here's the graph. The red buggy actually went more distance in the amount of time it's given, while the blue buggy didn't cover less.
Does anyone want to say anything?
What?
Okay. So you have a question over here.
Oh, we forgot to label that.
So what would be on your y-axis?
Oh, the distance.
Okay. Which is your what?
Time variable.
Okay.
And the time should be on the bottom for x.
All right. Very good. Thank you much.
Well, we're doing the buggy. We didn't have time to label our graph or anything, so we're doing the buggy lab, and the green is the red car, and then the black is the blue car, and down there is the time in seconds, and over there is the distance in meters or centimeters.
The graph is telling us that the red car traveled a greater distance in the same amount of time. The red buggy was faster because after 25 seconds, the red car went to 1,007.7 centimeters, and the blue 461.9.
Excuse me. Cough. Okay. Any questions? Nobody's gonna see it.
They forgot to put the title.
Okay. Well, that's one thing. It is missing a title, so you should have a title. But I think when they said they didn't have a chance to finish labeling, I think we kind of will include that in that. Anything else? Yeah.
I think centimeters.
What unit did we agree upon using, guys?
Meters.
We agreed upon meters. So how would you convert centimeters to meters? What would I have to do? You'd have to move the decimal. How many places? Two to the
Right.
left. There you go. So that 1,007.7 centimeters would become 10 meters, 10.07 meters.
Okay.
Okay? But still, numbers are all good. Graph looks good. Good job. Thank you very much. Go ahead.
Alright, this is our graph right here. The blue car is the black color, and the red car is the red color. And what this graph is showing the distance in meters that the buggy's traveled in meters, and then the graph goes in 5-second intervals, so every 5 seconds. And then
the red buggy went faster. The graph, the red buggy is red, and the both buggies have the both same amount of time, and the red buggy, the line is bigger than the blue one.
Okay. Anybody? Questions? Clarification? What do you mean by bigger? What do you mean the line is bigger than the blue buggy?
it's higher than the blue.
So is bigger really the right word to use?
No.
So the line went higher would probably be a better word to use in that case. Okay, excellent. All right, thank you very much. All right.
Well, we did the buggy lab. For the independent was time, and the dependent was distance. This red line is the red buggy, and the blue line is the blue buggy. And the question that we had was which car was the fastest? The red buggy was the fastest because the red buggy was going 1.5 centimeters faster than the blue buggy.
Okay. Questions? Corrections? Issues? Nobody sees it? Oh, we got one. We got a couple. Chastity, you calling them, not me.
David?
You didn't put the units.
We're missing units. So what is our units for our time?
Seconds.
Okay, and what was our units for our distance?
Here.
Okay, now based on that, does anyone else see the other issue?
She didn't mark it for meters by the distance.
Okay, well, she said that she was going to do meters. Okay, she has meters for distance and then seconds for time. But seeing that, there's another error somewhere that we need to find. Does anyone else see it?
She didn't mark the color of the thing.
No, she said what they were. Well, she didn't put it in a key. I mean, that's what she should have had a key. Well, what? What do you mean? Ah. So why did you put 1.05 centimeters in your proof?
Because I added it.
Okay.
I,
But should it have been centimeters? No, because centimeters, that's about the distance, I don't know, between the letter B and the beginning of the letter B and the end of the letter U. If the two cars were going that fast, or if they got that far, both of them, that's pretty much the same speed. That's not very different. So you got to make sure we have our right units. Okay, very good. Good catch, Rashid. All right, thank you very much.
Okay, so this is our graph. This is the blue buggy and this is the red buggy. What the graph was trying to tell us is that both buggies were moving at a constant speed, but one of the buggies was going farther than the other buggy.
The red buggy went faster than the blue buggy because the red buggy went 7 meters farther in the same amount of time.
All right, so do we have observations? Huh? Okay, so you have graph for your title. Could there have been a better title to give?
Buggy lab graph.
Buggy lab graph. Okay, so that would be a good one. So yes. Okay, excellent. Very, very good. Go ahead.
which buggy is faster?
This graph is showing that the red buggy went a further distance than the blue car in the same amount of time because of the line and they were higher.
According to the graph, the red buggy went farther than the blue buggy at the same amount of time. So therefore, it's faster.
What do you mean by according to the graph, the red buggy went farther? How do you know that? Because the line went higher. Okay, excellent. Alrighty, thank you very much. Excellent, excellent.
The red buggy was faster because it went at a faster rate of meters per second. The average amount of meters the red buggy went during our first 3 5-second trials was 2.35 meters, while the blue car's average was 1.41 meters.
Our graph shows that the red car is much faster than the blue car because the red car got to the locations faster than the blue car and could in 5-second tries. Our graph shows the time in seconds and distance in meters that the red car beat the blue car by.
Rashid? What? Title. Okay, yeah, so you guys are missing your title. Got to remember you have a title for a graph, but otherwise, is there any other issues with it? The only thing I would say is you guys notice how you have 2, 4, 6, 8, 10, 12. You went by units of 2 for your x-axis scale, your independent variable scale. Did you really need that in this particular case?
No.
No, you could have gone just by 5s and been okay. It's not bad. It's just more writing than you would have had to do. So, all right, but still, very good. Thank you very much.
Notice that the red car went higher than the blue car because it was obviously faster.
Right, basically what our graph is saying is that the blue car moves at a smaller rate than the red car.
And the red car was faster because it had a much higher standard than the blue car.
Much higher standard? What's a standard?
I forgot what it was.
What do you mean by standard?
Sort of like went sort of faster.
Okay, so it went faster. All right, you don't need to say another word just to say another word. All right, so any questions, clarifications? Really? No one's really hit the obvious one?
Nick?
Okay. No one else is going to hit the obvious one aside from the title? Really? No, what you're going to make me take points away? No one's going to question something?
Gavin?
What are the units for time and distance?
Meters.
So time is meters too?
No, time is distance was meters, time was
Did you wait 5 minutes?
No,
5 seconds.
There you go. So your unit was seconds. Anything else? No one over here. Did they necessarily mess up on the graph? So if your data supported a graph like that, does that mean you messed up on the graph? No. That just means we have a potentially a bad set of data. For all you know, everyone else could have been messed up. Okay, so what we could ask is, how come, why is the blue line above the red line for so long and then it switches? What happened?
I forgot to erase it and like fix it.
Oh, so it should be a straight line?
Yeah, it should be a straight line.
Ah, okay, so you,
Not enough time to change.
okay, so that should have been something you started off with. Okay, because to me that shows me that the blue car started out faster and then slowed down.
Yeah.
Okay, excellent. Still very good. Thank you for that.
This graph is showing which car is the fastest in time, the faster one in time and in centimeters, and how far it goes. The red buggy is faster because the average is higher than the blue car. The average for a red one was 714 centimeters, and the blue one was 541 centimeters.
You don't need to clap. You don't need to clap. Okay, so anyone see anything that they might want to address?
You guys measured in centimeters, but you're supposed to do meters.
Ah, so we agreed upon meters when we first had our discussion in the beginning. So we decided on meters. Okay, so is that a crucial issue?
No.
Not really, because it just means we have to change the numbers, huh? So instead of it being 500 meters, it would be, or excuse me, 500 centimeters, it would be 5 meters. Okay. All right. Now, I do have an issue, and this one's kind of like being able to understand it. The issue that we have here is having to do with the how your proof for number 3 there. Your proof, you said it. The red is 714. What's that say? Average? What do you mean 714 average? Ah, so that means it's not that it went that far, so that's how far it went over the total time. Okay, so that's just a little bit of a clarification you need to make. Okay, but still, very good, very, very good. Okay, don't worry about it. Go ahead.
So basically what our graph is showing is that the red car is faster than the blue car. According to the graph, over a period of 25 seconds, the red car was faster than the blue car. As you can see on the graph, that the red car traveled a farther distance than the blue car did in 25 seconds.
Questions, anyone? Clarification?
I like the car.
Okay, so what about your graph is saying that the red car is faster than the blue car?
Wait, what was the question?
What you said in your graph for number 2 right there? You said what our graph is saying is that the red car is faster than the blue car. What about your graph is saying that?
The points that we plotted, because it shows that it traveled in the time that both cars traveled. The red car traveled a farther distance, which means that it must have been faster to get to that point.
Okay, very good. Thank you much. All right.
What our graph is telling us is that the red car is faster than the blue car. The red car is faster because our graph shows that the red car is higher and the numbers are bigger than the blue car. And that's
Show the class, don't show me. Okay, so are there any issues we have with this? Jocelyn?
They didn't put the title or the units either.
Okay, so they didn't put title or units either. Okay, what else? Anything else? G? No key either. Okay. So kind of just basic graph identification stuff. Very good. Anything else? Ah, they don't have their evidence. Guys. Oh, average? Evidence is another one good one. Because although you guys said, now you said in your graph because the numbers are bigger than the blue car. I see two sets of numbers. I need more than just numbers. Evidence should be specific. Okay? So, and that's something that the first two groups kind of missed as well. Kind of. Some of you kind of hit on it. But if there's a bigger number, what's the numbers? Give me the exact numbers. Be specific. Okay? So still, but very, very good. Excellent. All right.
The graph shows us the distance in meters over 5-second intervals in each car.
Show the class.
Oh, show the class.
Yeah, there you go.
The red car was faster as shown by our graph. It went farther over the black intervals than the blue car.
And this is shown by our averages. The red car got an average of 10.17 meters after 25 seconds, and the blue car got an average of 5.56 meters over 25 seconds.
Okay, so I'm just going to go ahead and chime in here, guys. So you see what I was talking about on the last one. You see how I said you need to have specific data, or excuse me, specific proof. You see how on the proof at the end there, they have their average distance over the time, over how long? That's specific. It gives you exactly what we had, okay? So we're going to go into that a little bit more too as we continue with this unit, but still very, very good. Okay. Go ahead. So what are they missing, guys? Nope, they have a key in the top right. Seth? The specific data. Okay, so you need to be specific on your data, so very good. Go ahead.
Okay, start. The graph is saying that the red car covers more distance than the blue car in less time.
The red car is faster than the blue car because according to the graph, it has a faster speed of covering more distance than the blue car.
The red car's average is 45 meters at 25 seconds.
And the blue car's average is 17.92 meters at 25 seconds.
Okay. So, does anyone have any observations or questions about this? Really? No one has any questions about this?
I circled the time right there.
There's nothing that looks odd about this?
Why is it graph like that?
Say what? Say it.
Their graph is different than it's like how they plot.
So there you go. So we have a question. We now have data that's looked different than every other group's data so far. Why does your graph look like that? Because you had a buggy blue car?
No, like the battery, it kept dying out.
On the blue car or the red car?
The blue car.
Okay, but
Why does it like?
then why does the blue car go farther than the red car if the blue car kept dying out? So what that is when you have multiple different individuals who have a specific set of data that looks a specific way, and you have another group that looks different, what can you think about that group that has different data?
They're different.
Okay, maybe they did the lab differently. Okay, Is it possible that we could have had some problem with one of their buggies?
Yeah.
So there could be there could be an error in the experiment, but do we discount their data? Never, because their data is just as important. Okay? But what that does is that gives us the opportunity to stop and look and say, hey, wait a minute, why is theirs different than ours? Okay? There's always someone that has a different set of data in this lab, always, and that's a good thing. Okay? Very, very good. Thank you, sir. Oh, look, we're getting the argument on camera. Let's go.
The graph shows that the blue car is faster than the red car. It's faster because the graph shows that the blue car goes a longer distance than the red car in the same amount of time.
Now, is there anyone who has any questions about? Apparently, we have a lot.
Oh, wow.
You pick.
Oh, okay.
Alright, how come, if this is a meter, how come you have 100, 200 instead of 1? That means that's 100 meters.
Which is 100 of those meter sticks. So that means while you said it's in meters, what did you actually measure it in?
I actually measured it in centimeters.
Okay, so we need to make sure we change those numbers. So that's a catch. So you can thank Ethan on that. What else? You have a hand over here.
Oh,
It's no interval for time at the bottom. For the x-axis.
It's on the right.
Oh, well, I missed that.
Okay, now I am going to chime in about your two axes. Okay, now on the left side for our independent, or for our our dependent variable, what do they have the dependent variable labeled as? Okay, is that what it is, or is that the unit?
The unit.
That's the unit. So don't stand on those, please. So we don't want to do that. Okay, we want to include the unit, but we want to say what it is. So what should that y-axis be labeled as? Distance. Okay, so distance with meters is the unit. They did the same thing on the bottom. They just wrote seconds. Okay, so it should have seconds, but it should also have what? Time. Okay. Now, what's the big question? Go ahead. The blue car won instead of the red one. Now, there are multiple different things we can say here. But, excuse me, but do we discount their data?
No.
Never. Okay? So, there are multiple things. Maybe they actually had a blue car that was faster because as the time went on, the red cars did get a little slower because their batteries were dying. So, yes, sir.
So there could be a possibility that when they were graphing it, they when they were when they were writing down the numbers, that they mixed it up because it looks like that looks like almost everyone else's graph except like
They're switched. And that's also a possibility too. So maybe you guys switch your numbers. You might just want to double check. But if that's your numbers, then what do you do? Do you keep those numbers?
Yes.
Yes. Okay. Very, very good. Take us away.
The graph is saying that the red car is faster than the blue car. The reason we came to this conclusion is because based on the evidence for our data we received from our experiments.
Okay, so what are they missing, guys?
Just like the other group, they forgot distance and time.
Yeah. So they gave us units instead of what it is, and what else?
They have no specific.
No specificity. Okay. Now, no specificity. So that's just basically a simple thing. So very good, very, very good. Good job. Thank you much.
Alright, so the graph is showing us that the red car went faster significantly. One of an example of this is the fact that the red car managed to reach 12.5 meters in just 25 seconds. That's the highest distance that it managed to reach, while the blue car only managed to reach 5.8 meters in 25 seconds.
Anyone have a question? I do. Why does your last point go down? Did your car reverse? That doesn't make sense to me. Why does your last point drop? Seth? Ask them, not me.
Is it because, did you guys measure each 5-second interval or all together?
5 seconds.
Ah, was that what we were supposed to do?
No.
So you were supposed to add them together, so we have an incorrect line. So we have to fix that. Good catch. Very good. All right. So that would solve that issue. Okay, very, very good. Thank you much. Okay, go ahead.
Go.
This is our graph for the buggy lab. As you can see, the red car went longer in distance than the blue car. Our answer to number 2 is that our graph is saying the distance our cars went in a certain amount of seconds. Answer for number 3 is the red car is faster because it went more in distance than the red car. In 50 seconds, the blue cars in average went 8 meters, while the red car in average is 24 meters. Any questions?
Questions, comments, corrections, observations. So what do they include at the end of their question number, their answer to number 3? What do they include there? They included like just their average what? Well, they didn't say speed. Car distance. Okay. So the average meters. Very good. So we had the average meters there when it came to that. So yeah, very, very good. Excellent.
2, 1, go.
The graph is saying which car went faster than the other in 50 seconds, while the distance they went was measured in meters.
The red buggy is faster because in 50 seconds it went 21.33 meters, while the blue buggy went 7.
Okay, so I have a question, and this is not one that's a correction or something. I just have an observation question. What do we notice about the shape of those lines of those two cars? What do we notice about that? They're what? They're fairly straight, right? What was one of the observations that we made about the car when it came to its speed? It stayed fairly constant, right? So do you think that those two things have some sort of correlation? Do you think they tie in together at all? Probably. You think that's maybe something we might want to be paying attention to as this unit goes on? Probably. Might be another idea to think it is because the teacher's bringing it up. I don't know what you're saying. Any questions, observations? No. Okay, well that's that one. No? So no one sees any issue with this?
Not the reserve issue.
Look at the board, guys. I don't know why you're looking at me. I'm not the graph. The graph's over there. What's wrong? There is one thing wrong with this.
No time for the graph.
It's there. It's your graph. You gotta have time. So this one is missing its time. Okay. Minor, but that's just one of those things. That's why I want you guys to catch it. All right. So very good. Thank you very much. All right. Next group.
1, go.
The graph is telling us the distance between the two buggies. The red buggy went faster, as you can tell in the graph, and our proof is our averages.
Oh God.
Hold up. So they're done talking, guys. This is your turn.
I know.
All be very quiet. We're hunting rabbits. Ha ha ha. What's up? We got a hand over here, guys.
Timer. When the buggy went a constant speed, going up.
So wait a minute. So what's your problem?
It's staying the same.
So you don't like to look at the graph. So
No.
you say it went.
It just looked like it stayed still because it wasn't moving up.
Okay.
We got to.
Okay. So you're kind of on the same thing. You say the graph is wrong. So it looks like it's staying the same. All right. So that doesn't really tie into it. So what do you think they did? They already know. I already talked to them. Okay. So what do you think is a problem with this graph. So you guys already noticed that there's something different with this graph.
They don't have their units.
We'll get into that in a minute. Okay.
Their averages,
What do you mean their averages?
they,
Don't say I don't know. Give it a shot. You said their averages. I just want you to clarify a little bit.
they didn't add them all up.
Ah, so does that kind of look like it'd be true? Does it look like they kind of, that it might be that they didn't add them up?
Yeah.
Okay, because if it's going to constant speed, should each segment be about the same amount, same distance? Okay, so that kind of makes sense for what they're doing. All right, now let's get into anything else that's wrong potentially with the graph itself, because we got the line issue taken care of, and that was a big thing. You guys caught that right away, which is great. All right, now is there anything else wrong with their graph? They don't have their units. So what's your units for your independent variable? Folks, what's your unit?
Second.
Huh?
Seconds.
Seconds. So you need to write seconds. What's your unit for your dependent variable?
Yeah.
What is it? You better know because it's what we agreed upon.
Meter.
Oh, yeah.
Yeah, it's meters.
Yeah.
Dang. 600 meters?
Oh, because we did it wrong.
Well, what do you mean you did it wrong?
We talked about
Not
this
really.
earlier.
Okay, if you look at the line,
That's pretty big.
and what do you think we're going to do right now? Okay, we're going to work through it.
I know.
So where's your red line? Hold up a little bit because Megan's head's in the way right now. So okay, so your red line, you're saying that each segment went about 400, you said meters. That means your red car in 10 seconds traveled the distance of 400 of these bad boys. That is a really fast red car. I think that thing, if I'm not mistaken, I think that thing's doing about 35. Okay? So what do you think your guys, in your case, what do you think your unit you used was?
Yeah.
What'd you use?
Centimeters.
Centimeters. So what do we have to do to convert it?
Move the decimal.
Beautiful. We got that catch, okay? So that is caught. Very good. So we've got 2 of our issues. There's still one more. What? Same one that's been on the last 2. No title.
That is our title.
That is your title?
That is a title.
Okay. To me, it looks like your question for the lab, but would that work as a title?
Yeah. Yes.
Yeah, it would. So
Yeah,
excellent.
title.
All right. Thank you very much. Good job.
3, 2, 1, go.
Alright, so our graph is showing that the distance in meters, what the red and the blue buggy went in 50 seconds, our averages for the red buggy in 10 seconds is 4.26, 20 seconds 7.45, 30 seconds 11.3 meters, 40 seconds 17.11, 50 seconds 20.69, and the blue buggy is 10 seconds 2.5, 20 seconds is 3.91, 30 seconds is 5.91, 40 seconds is 7.3, and the 50 seconds is 8.8, and then pretty much.
So which one was faster?
Oh yeah, the red buggy was faster.
Because
the averages.
What about it?
How far in meters they went in a certain amount of seconds.
Okay, that's what the averages are. But
Yeah.
What about the averages tells us that the red car's faster?
Shoot, I really think
Do.
Come on, Julian, you got this.
What'd you say?
What about your averages tells us, proves to us that the red car's faster? Proof. Everything's got to be based in proof.
Probably staring at
Who
it.
wants to help them out? Julian, you got people willing to help you out?
Okay. What's the question again?
You don't know the question, no. Julian, pick someone else.
No, I got this. Okay, the averages show that the red buggy went faster in the amount of time.
You said that.
That's what he just said.
No.
Go with someone else, Julian.
Oh, you wait. Okay.
What's more proof?
The red buggy went faster in the same amount of time, so or it went further in the same amount of time.
Okay, so that means the numbers are Yes, that's your proof.
Okay.
Okay, the actual numbers being higher, that's your proof. All right, so, excellent. All right, are there any questions about the lab? Or, excuse me, not the lab, the graph? They got anything wrong with it?
No.
Oh, yeah.
I see a title, I see a key, I see labels, I see shapes. You got something?
Yeah.
What?
They didn't put meters.
Yeah, they did.
On the distance in meters. No, yeah.
Well, he was saying it, but yes, you are right. When he wrote his data down, he didn't include a unit. Go ahead. Okay, now they forgot something. Because what did we have? Where did we start from?
The line.
We started from 0. We started from the line, right? Boy, should they have connected to 0?
Yeah.
They should have. Okay? In this case, because we started from 0, you should start from 0. Okay? Very good catch, Megan. I actually didn't even think of that one. Because of that. But good job. All right, excellent. Very good. Next group.
Which buggy's faster? The graph is telling us that the blue buggy is faster.
Louder, guys. I can't hear you and I'm standing right here.
The blue buggy is faster because it went further. In 50 seconds, blue went 38 meters and the red went 36.6 meters.
What?
Okay. Questions? Concerns? Comments?
You don't have a title. Unless that's your title.
They do have a title.
Okay. They have their key, it's just at the bottom. They have their labels. Anything else? Anyone else? Really? No one's going to...
Quite obvious.
It's the obvious one. Go ahead. Go ahead. Yeah.
How is a red car faster? I mean slower.
We have conflicting data.
What was that?
According to this, what did they say that which was faster?
The blue.
The blue one.
Why?
Now, first and foremost, is their data wrong?
No.
No, data is never wrong. Okay? Never, ever can data be wrong. Could how they did the experiment be there be a flaw there?
Yeah.
There could be a flaw there, but is that okay? Yes. Because this gives us another aspect. Because now we can analyze where do we think a mistake might have been.
Maybe the battery.
There you go. Maybe there might have been a battery issue. Maybe the red car they had, because I did have to change a couple of red car batteries. Maybe their battery on the red car, the one they chose, was just dead. So will that have an effect on their data? Yes. But do we discount their data?
No.
No.
Yes.
Always include data. That's huge in science. Okay? Very good. Okay, what else? What could have also been a potential, could there have been something else that there might have been an issue? Measuring, maybe they measured wrong. Last class we had the same thing happen. Someone suggested, is it possible that they could have, when they input their stuff into their data tables, that they accidentally flipped which one went where? So they accidentally put red and blue and red. Is that a possibility? Yeah. Okay. So, but if you kind of look at it, look how close they are. If you look at how close they are, and then you look at the fact that red's really dying out towards the end, to me it looks like, is it likely that the battery was probably dying on red?
Yeah.
Probably. Okay? But we don't discount it. Still excellent. Thank you very much, gentlemen. All right.
3, 2, 1, go.
Alright, this is our buggy lab graph, and the graph says that the red buggy is faster because the red, it went, in the same amount of time, it went further, as you can tell from the graph. This one went about like 7 for average, right? And then this one went 18, so it's showing that the red buggy is faster.
Concerns, questions, observations?
Good job.
I have a question. Why, at about 20 seconds, does your red car go? See that?
Oh.
Why does it speed up? Why does it look like it speeds up all of a sudden?
It's just kind of like how the line got, like.
We kind of had
Like,
it.
because it's like kind of.
We had to push it so that it wouldn't get in the way of other people. So that
Okay,
might
so
have.
we have, maybe it had to do with the scale because you're not using an actual graph, but then also maybe because apparently you guys had to interact with the device. So does that mean it could have had an effect on your measurements?
Yes.
Okay. So very, very good. Excellent. All right. What groups haven't gone yet, folks?
3,
Go, guys.
2, 1, go.
Start off the video laughing.
Starting out the video with a giggle. Let's go.
This is our graph.
No say.
And
What is it telling us?
okay, it's telling
Use
us
your
that
labels.
it's telling us that the red car went faster.
How?
What do you mean how?
How is it telling us the red car went faster?
Oh, because of our
Reason?
graphs, there are dots.
So the dots are saying,
No, the average, our data.
So the averages are saying, hey, we're faster.
The data, the
Details.
data, the data.
What about the data?
The data is showing us that the red car went faster than the blue.
How?
By timing it. By measuring
So
it.
the
By
numbers
measuring
are out there
it.
going, all right, go.
By measuring it.
So the numbers were doing the measuring, not you?
No, by me measuring it.
Okay, so what are those?
Measurements.
Okay, so how can you tell using the measurements that the red car went faster?
By my measurements.
Do you know that if you look under in the dictionary on the word redundant, it says see redundant?
What?
I just said the same thing.
Oh. I'm
So
lost.
I can tell.
Wait.
How can you prove? If you were to walk up to someone and say, here's the two buggies that we've had to test. The red one is faster than the blue one. Here's my proof. Blank. Tell me what the proof is. You can't just say my measurements. I need more details than that. You need to be more specific.
Okay. By when we timed it and we like measured the intervals.
Let them go.
We when we measured it, it told us how fast it was going.
No, it didn't.
Or it showed how fast we were going.
No, it didn't.
Yes, we did.
It did not tell you how fast it was going, nor did it
We
show you
showed how
fast
far it was. How far it was
How
going.
did it? How what?
Far.
How far it went. Now, how is that going to tell us which one's going faster?
Because that's the distance it was going.
In
Meters. Seconds.
okay,
Seconds.
right. How far it went in meters over
Seconds.
seconds. Now, did the amount of seconds change?
No.
So that means in the same amount of time.
It was going a farther distance.
All right! Woohoo! We got proof.
Yay!
Thank you. All right. Questions.
You guys forgot.
Wait, I know we forgot the title yet.
Okay. She didn't. No.
We got that.
All right.
Jump
We
on
got our label. Still very good. All right. Excellent. Had to draw it out of you, but we still got it. Very good, guys. Okay.
3, 2, 1, go.
So as you can see here, well, I'm just gonna say it. Yeah, we forgot to add a scale and a title. So, but anyways, as you can see on here, the data is saying that the red boogie is faster than the blue boogie. Evidence for this is that the fact on these results that the red boogie's average on the 3 trials were greater than the blues. Does anyone have any questions?
Does anyone have any questions? Sounds like the dude from, it's older than you guys know, but
Australia.
Lifestyles and Original Things. Old show, back in the 80s. It's like
No
Arnold
questions.
Schwarzenegger.
We answered them all.
All right, very good, thank you.
All right.
All right, ladies and gentlemen.
Man.